This is section 10.3, Formulas in 3 Dimensions. The objective of this lesson is to develop and apply the distance and midpoint formulas for 3 dimensions. We're going to start this by looking at the diagonal of a right rectangular prism and how we can find that length. Here we have a diagonal D, and it is connecting 2 different vertices on 2 different faces of the prism. So we're going to look at how we can find the length of that diagonal D. I'm going to use the length, the width, and the height of this rectangular prism to find it. I can use Pythagorean theorem to find the length of x, which is the diagonal of just one of the bases. So here, this rectangular base at the bottom, I can find the length of x squared, and it will equal L squared plus W squared. And x is one of the legs of this right triangle here that's created with the diagonal D, x, and h. So I can use Pythagorean theorem again to show that d squared will equal x squared plus h squared. So I know that x squared is L squared plus W squared. That can be substituted in here. And then we can solve for d. And that gives us the formula that we can use to find the diagonal of a right rectangular prism. Diagonal d is equal to the square root of length squared plus the width squared plus the height squared. So let's do a couple of examples with that. For example 1, it says find the length of the diagonal of a 6 by 8 by 10 centimeter rectangular prism. So here's the prism we can look at. We're trying to find the length of the diagonal. If the length is 6, the width is 8, and the height is 10 centimeters. So let's use our formula. D will be the square root of 6 squared plus 8 squared plus 10 squared. Simplify that, we get the square root of 200, and that is approximately 14.1 centimeters to be the length of diagonal D. Let's try another one. For example 2, we're going to find the length of the diagonal of a cube with the edge length of 5 centimeters. Okay, so here's a cube. We know that if it's a cube, all the sides are the same length. And using the same formula, we end up with approximately 8.66 centimeters as the length of the diagonal of that cube. Now let's look at 3 dimensions in the coordinate plane. Space is considered the set of all points in 3 dimensions. In space, we need 3 coordinates to locate a point. The 3-dimensional coordinate system has the x-axis, the y-axis, and the z-axis. Each point in that space can be represented by this ordered triplet. In a 2D plane, we call it an ordered pair. In a 3D space, we call it an ordered triplet. Our x-axis is going to be moved forward or backward. The y-axis will move right or left, and the z-axis will move up or down. And the origin is always at where all 3 of those axes intersect, and it is at 0, 0, 0. So here you have an example of where the point 3, 2, 4 is located. If you were going to plot a point in that 3D space, you would start at the origin, you would move 3 units forward, 2 units to the right, and 4 units up. And that would give you the location of point 324. In example 3, we're asked to graph a rectangular prism with length 5 units, width 3 units, and a height of 4 units. And it has one vertex at 0, 0, 0. Okay, I know I'm going to start at the origin. It's a rectangular prism, and I'm going to have my height along the z-axis. So I know I'll have a base that is a rectangle in the XY plane. So if the base is 5 by 3 units, so it's 5 units long, 3 units wide, I can find that point 5 units along the x-axis, 5. I know it'll go to here, and I know that it will go 3 units up the y-axis. So that would give me a 3 by 5 rectangle. And go ahead and draw that in. And then I know it will be 4 units high. So I will go up the z-axis 4 units. And it will do that from every one of those vertices of my bottom base. And then I can connect those to create my top base. So that's one of the possible ways to graph the rectangular prism. That's a 5 by 3 by 4 units. Now we're going to talk about finding the distance between and the midpoint of 2 points in 3D space. First, the distance between 2 points. This formula probably looks familiar because this is the portion that we use when we talk about 2D distance. When we find the distance between 2 points in 3 dimensions, we also have to factor in the distance between the z coordinates. So we have the difference in the x direction squared, plus the difference in the y direction squared, plus the difference in the z direction squared. And then we take the square root of all of that to find the distance between those 2 points. Midpoint is similar to the midpoint in 2 dimensions. We add the x coordinates and divide by 2, add the y coordinates and divide by 2, and add the z coordinates and divide by 2 to find the midpoint of the segment with these 2 endpoints. For example 4, we're going to find the distance and midpoint for the given points. We're going to round to the nearest tenth if necessary. Our points are 0, 9, 5 and 0.6012. So let's find the distance first. We're going to use the distance formula that we just saw. Okay, I use this as 0.1 and this is 0.2. And that's where I found my x1, y1, z1, x2, y2, z2. Okay, when we simplify, we find that the distance is equal to the square root of 166. So we can approximate that and round it to the nearest tenth, which would be 12.9. The distance is 12.9 units. Let's look at the midpoint. For the midpoint, we add the x coordinates together, divide by 2, and so on. Here's what I get when I substitute in my coordinates. When I simplify, I find the midpoint is 3, 4.5, and 8.5. Here's an example for you to try on your own. Haley drove 10 miles east and 22 miles south from the cabin while gaining 0.1 miles in elevation. Kason drove 8 miles west and 16 miles north from the same cabin while gaining 0.15 miles in elevation. How far apart were the two drivers? So here we have 2 points in 3D space. You can use the distance formula to find the distance between those two drivers. Bring that with you to class tomorrow and we will start the discussion with this example. See you then.